Okay, geometry fans, our topic for today is polygons and angle measures and tessellations. Okay, so we're going to go through a bunch of different topics today. Before we start the lesson, let me tell you your joke of the day. So the proton was talking to the neutron. The proton said, I think I lost an electron. The neutron asked him, are you sure? The proton said, yep, I'm positive. All right, so let's start with definitions of polygons. The official definition of a polygon, it is a closed figure formed by a finite number of coplanar segments such that the sides that have a common endpoint are, we say, non-collinear. We're going to draw this in a second, okay, so just write this down. Each side intersects exactly two other sides, but only at their endpoints. So the idea of a polygon, the sides that have a common endpoint are non-collinear. All right, so for example, if I take a triangle, that's a polygon. Okay, and I can put 3 points on there. I can name the points A, B, C. If I put a fourth point on here, let's say I put one here and I call that D. Did I just make this a four-sided figure? Because now I have 1, 2, 3, 4 segments. But because D is on the same line as A and C, they are collinear. That's still one side. This is still a triangle. Okay, so the idea is that the sides that have a common endpoint, they have to be non-collinear. So like BC and AB, those are different sides. They have the same endpoint. They're not on the same line. Okay, and the second part of the definition is that each side intersects exactly two other sides, but only at their endpoints. If I take a figure such as this, and again I'll call it ABCD, I cannot call this a quadrilateral. This is not a polygon. Why? Because two of the sides, AC and BD, meet at a different place. They don't meet at A or B or C or D, they meet somewhere else. Okay, so they have to have the same endpoints. If I take, for an example, okay, I'll draw a triangle again. Okay, so triangle A, B, C. So AB and BC, these two sides intersect, but only at their endpoints, right there. Okay? Now, some other examples here of polygons. One that you're probably familiar with, that's a hexagon right there. Yes, that's a polygon. Triangle, yes, that's a polygon. If I pick 2 points in this hexagon and connect them, notice that all the points on the segment are also inside the hexagon. We call that convex. That's a convex polygon. Now, if I take a different kind of hexagon, let me draw it. 1, 2, 3, 4, 5, 6. This is also a hexagon. 1, 2, 3, 4, 5, 6 sides. But if I take 2 points here and I connect them, notice that some of the points on that segment are outside the figure. This is what we call concave. It is a polygon, but it's not convex. Now, something that's not a polygon would be a circle, because a circle has no sides. So that's not a polygon. Concave is, we're not really going to look at concave, we're going to look basically at convex. And the key thing for today, almost all of our examples are going to be regular polygons. Regular means a convex polygon with all sides and all angles congruent. All sides and all angles congruent. This is really important. You need to know this word, regular. In geometry, it means all the sides are congruent and all the angles are congruent. Now, what we're going to do here is we're going to look for some patterns. So you have this big chart, and we're going to fill this thing out. Okay? And there's not a lot of space. We're going to draw some pictures on the side here. And the columns, regular convex polygon, we're going to put the name in there. N is the number of sides. N is the number of sides. So 3 all the way up to what we say is N. Number of triangles, sum of the interior angles, measure of one interior angle, measure of one exterior angle, sum of the exterior angles. As we go through, I'll explain this, but we're going to fill out this whole chart. The first one we're going to start with, the most basic polygon we have, is a 3-sided polygon, which is what we call a triangle. Now, if it's regular, all the sides are congruent. Okay, now we're going to draw this on the side. Okay, all the sides are congruent. All the angles are congruent. Well, we have a name for that. That is an equilateral triangle. Equilateral triangle. Okay? The number of sides is 3. Now, the number of triangles, right now this is not going to make a lot of sense, but in this picture we have one triangle. The sum of the interior angles in a triangle, if you add up all the angles, we always get 180. Okay? One triangle times 180 equals 180. Now, the measure of one interior angle, if all of these are congruent and they add up to 180, it would be 180 divided by 3, which is 60, 60, 60. Okay, so I can take 180 divided by 3, and what that gives me is 60 degrees. Okay, I'll put that in green, 60 degrees. Now, the measure of one exterior angle. The way that I get an exterior angle is if I extend one of these sides. Okay, now that's an exterior angle. Okay, that right there, I'll put EXT, exterior angle. If this is 60, then this would be 180 minus 60 because that's a straight line. So those two angles are supplementary. So I would do 180 minus 60, and what I get is 120. 120 degrees. And then the last one is the sum of the exterior angles. So if one exterior is 120, I could take my picture here and I could extend all the sides. And notice I'd get 1, 2, 3 120s. I'd have 3 of those. So the sum of those would be 3 times 120, which is 360 degrees. Okay, so there's the first row. All right, now let's move on to a 4-sided regular polygon. Now we have a name for that where all the sides are congruent, and what we call that is a square. Number of sides is 4. Number of triangles, here's what that means. If I take one vertex, one point, and I draw a diagonal, right there, I just split my square into 2 triangles. Okay, so I have 2 triangles. Now, you know that in a square, 90, 90, 90, and 90 is 360. But you could also think about it as, hey, 2 triangles, each triangle is worth 180, so that adds up to 360. Okay? The measure of one interior angle is 90 degrees because 360 divided by 4. So 360 divided by 4 is 90. Now, an exterior angle, well, next to a 90 degree, that would have to be another 90 to add up to 180. So the exterior angle would be 180 minus 90, which is also 90 degrees. Now the last thing is the sum of the exterior angles. Here's the deal. If you have 4 sides, then you have 4 interior angles, and you have 4 exterior angles. So if I go all the way around the figure, each exterior is 90. 4 times 90 is 360 degrees. Okay, let's go ahead and try a pentagon. Now, a pentagon has 5 sides. Pentagon has 5 sides. Now, it's going to look something like this. Okay, there's an example of a pentagon. The number of triangles. Now, what I do is I'm going to pick one vertex, and I'm going to draw diagonals from that vertex. I could go straight across, and then I could also go kind of this downward direction. Those are the 2 diagonals. I only draw diagonals from one point. So I've got now 1, 2, 3 triangles. I just divided my pentagon into 3 triangles. Now the sum of all those angles, the sum of the interior angles, that's inside, well, if I have 3 triangles and each triangle is worth 180, 3 times 180, which is 540 degrees, that's the total. That's all 5 angles together. Okay? So how do I find one of those? Well, I take the total sum of the interior angles, 540, and I divide by how many angles in a pentagon? 5. So 540 divided by 5 equals 108 degrees. Now that is an interior angle. That's inside. Okay, so how do I find exterior? Exterior would be if I just extend this. So this is 108. I would do 180 minus that to get the exterior. So 180 minus 108 equals 72 degrees. Now that's an exterior angle. In a pentagon, though, if I draw this, 5 sides, and then I'd have 1, 2, 3, 4, 5 exterior angles. So if I have 5 of those, and each one is 72, what I get is 360 degrees. Now, at this point, okay, 360, at this point, do you notice any patterns? Maybe with the number of triangles, 1, 2, 3. Maybe with the sum of the exterior angles, 360, 360, 360. Notice that interior and exterior add up to 180 every time. Now these are all patterns. Let's go ahead and do the next one, which is a hexagon, and see if this continues. 6 sides is what we call a hexagon. Now a hexagon is kind of like if you've ever seen a honeycomb, a beehive. It looks like that, 6 sides. Now remember, they're all congruent. If I divide that, I'll pick one point and then draw diagonals. 1, 2, 3. Now I can't draw any more diagonals from there because those are just sides. 3 diagonals, but how many triangles does that create? 1, 2, 3, 4. So the number of triangles is 4. Each of them is 180 degrees. So if I want the sum of all of these interior angles, 4 times 180 is 720 degrees. Now one of them, I would do 720 divided by 6, which is 120. That's an inside angle. So outside would be 180 minus that, because together they add up to 180. It's a straight line. 180 minus 120 is 60 degrees. And then the last thing, how many exterior angles are there? Well, in a hexagon, there's 6 of them. So 6 times 60, guess what? 360 degrees. Okay, so at this point, we're going to stop for a minute. I want you to do an 8-sided figure. See if you can fill this in, and then we'll come back to part 2 and see if we agree.